Hi, this is Brian Green. This is the GE Healthcare IT Talks podcast. And today I have with me a guest, Eli Rockers. Eli is an application analyst and was a research analyst at Houston Methodist in the neurological department. I'll let Eli kind of talk about his background, but the reason I asked Eli on the podcast today is, we're trying to cover topics that are of interest and useful for folks, in the enterprise imaging space. And I keep hearing over and over again about supporting research in enterprise imaging. But I'll let Eli go ahead and introduce yourself and talk to us about your background, what you do at Houston Methodist, and some grounding in what you do.
Okay, thanks, Brian. It's really good to be here. So you already hit the main points. I was a research analyst with the neurological department, working mostly in Alzheimer's, which is a very neuroimaging heavy kind of field of research. And I worked in a clinic where we basically had half clinic. We saw patients every day, and then the doctor that I worked for and his team, he got a lot of grant funding to do research on the side, and we were part of many different clinical trials. We worked with Mayo Clinic, Harvard, lots of different big Alzheimer's studies all over the country and actually all over the world.
Okay.
And I've just recently moved into the IT side for the entire research institute. So beyond just neurology and Alzheimer's, now looking at how we can bring imaging, the kind of stuff that I was supporting in the neurology department, to all the other sort of research departments and groups that we have at the hospital.
Let me ask you a question about the when you in this world where you have the use of a magnet and you're bringing the patients in just for the research study. Does that data ever bleed over to the clinical side? Like maybe there's some findings that, they have to go, maybe they refer the patient over. Does that kind of stuff ever happen?
That can definitely happen. Typically, there's a lot of different things going on there, but one of the things that could happen is maybe it's required for the PI to review those research images for certain signals, not just the signals that we care about for research, but say he's looking at a vulnerable population or something like that, and they need to make sure that whatever kind of study they're carrying out isn't affecting this, this particular participant. And so if they see something health related, that information can travel back into the clinical realm if needed. Usually what will happen though is if they find something on an image that's concerning, they won't send that image back to the clinic. They'll order another clinical image to be done specifically to target that, right?
Okay.
But there are other cases that I've heard of where, for instance, we will acquire a bunch of research data and then we'll have to send it somewhere else to be analyzed or processed, and then that will come back and be put into the clinical realm. But I don't know too much about that. So it's definitely a possibility that images specifically for research could end up in the clinical side, but they would have to be kind of re-identified.
So a question for you too is the thing that keeps coming up with these enterprise imaging folks. We live and breathe in Dicom, in the enterprise imaging world, in the PACS world, and some researchers are coming to these PACS and VNA admins and saying, I don't need Dicom. I need a JPEG, or I need some other format, some volumetric format, right? In your experience, is Dicom useful, or are they converting that data to something other than Dicom, or is it just a matter that some of the tools that exist in the research side of the world just simply don't use Dicom?
Yeah, so it took me a little while to understand how this all works, but especially for brain imaging with MRI and PET, and pretty much any other kind of volumetric imaging, they use what's called a NIfTI format, which is basically just a huge, stripped down by a huge amount. There's barely any metadata left. It's just kind of the volume, right? And for a long time, I used to think as a researcher, why would I ever want to use Dicom? It's so clumsy and cumbersome. NIfTI is so much easier to use. But the fact is,
is that because Nifty is natively a volumetric data set, whereas Dicom typically is the individual slices that you can reconstruct, and it just doesn't.
Yeah, exactly. And the thing is, there's so much. A lot of this actually goes back to how the research community is kind of built, right? Because the Dicom is really focused on the clinical aspect and making sure that all the medical devices conform and can communicate in the same way, and that when an
Right.
image comes out, there are certain criteria that it has to meet. With
Right.
Nifty, that's not necessarily the case, and that's okay, because in research you've got a lot of open access, a lot of
Yeah.
open source stuff going on, a lot of experimentation and research, not just on the images but also on the processes that you use to analyze the images and things like that. So Nifty is really a very flexible kind of a format to use for researchers. But I will
Okay.
caveat by saying that as somebody who's doing research, I have a lot more interest in keeping the DICOMs safe, right? Because when you convert something to a Nifty, think of you're making a Xerox kind of the source document, right?
Yeah. Yeah.
And you're going to do a lot of processing and analysis, maybe try a bunch of different things, and a lot of that stuff can kind of get a little bit confusing and messed up on your thing. You always want to have that DICOM source to go back to. Once you've figured out exactly what you need to do, you can say, okay, now I'm going to go back to the DICOMs, I'm going to get everything, and I'm just going to run the final pipeline, including converting it to Nifty maybe, but you always want to keep those DICOMs for sure.
Keep that original Dicom. It almost sounds like Nifty's a little bit more forgiving than Dicom in some ways.
I wouldn't even go that far. There's a lot of issues with Nifty too, in terms of the anatomical labeling. When I say that, I mean, are you sure that this is the left side of the brain or the right side of the
Okay.
brain, right?
Yeah.
All that stuff is in the DICOM headers, but Nifty can get so stripped down sometimes that
You're missing.
information can get lost and really cause a big issue.
Yeah, I was actually going to ask about that because there's a pretty rich set of metadata in Dicom. I mean, there's thousands of tags sometimes that contain metadata in Dicom, and when you lose some of that, I almost think that. And I was going to ask you about that. I mean, have you seen researchers using the Dicom metadata in the process of trying to curate data for these studies? Right, because you mentioned the EMR. The EMR would certainly tell you, how old the patient was, what their diagnosis was, what the outcomes were, and that sort of thing. But it doesn't tell you much about the actual study, right?
Right. It doesn't tell you what the repetition time is or the echo time for the MRI. All the kind of physics things that you want to
Right.
know when you're processing an image. Those are all going to get stripped away on a Nifty for sure.
Having a data lake to support research that's built on the clinical data is not something that's commonplace today. And what I think a lot of folks are starting to ask me is this going to be something that we need to support from the clinical side of creating these data lakes so that researchers can have access to it? The smaller hospitals, your 200-bed hospitals or community hospitals aren't worried about this yet, but most academic hospital systems are, right? They're starting to think about this.
Yeah, and so this one of the questions you asked earlier was kind of what would in an ideal world look like for researchers to be able to access all of these clinical images.
Yeah.
And I've been talking about this with somebody else on my team, and we were saying, man, it would be really awesome if we just had a separate VNA that was just a mirror of the original VNA, but everything is de-identified, and a researcher can go and query, the images that they need, and instead of getting the identified version, they just get the de-identified version that's somehow linked between these two VNAs, right?
So one of the challenges that because I've heard that, and what you just described is one of the methods I think a lot of folks are starting to gravitate towards. Let's just have a research VNA that is dedicated to mirroring all the data for researchers. But then the topic comes up about efficiency, because if you look at any given hospital, the vast majority of their data storage is radiology and cardiology, right? It's all this image data. It's like leaps and bounds more data than anyone else usually in the hospital system. So when you tell the hospital system, we're going to have to double that, right?
And so I've actually been pushing back on my teammate about this for that very reason. He's gung-ho about a research VNA, and I'm saying that doesn't really make a ton of sense, from an
Yeah.
efficiency standpoint. But when you ask me what the ideal solution is,
Yeah, that's it. Yeah. So what if there was a hybrid where you have this sort of a data lake that is the metadata of for the imaging data. You know, it's the Dicom headers essentially in
hmm
some data lake that you could that just has a pointer to the actual Dicom files in the clinical VNA or clinical PACS or archive or what have you. And then somehow when you go and get that data, if a researcher goes to get that data, it just gets automatically de-identified the version that they get.
right. So the version that they get would have to uh, be relabeled with a hash number, right? And that hash number has to be traced back to the identified information. So if they need to go back and forth, they can get all the images, but it doesn't help them if they don't know who the images belong to, because then they have to, they need to know the age and the sex of their participants.
Right.
That's stuff they need for their research, even though when they store the images on their own, if maybe they have a SQL database where they store all their images, they're
Yeah.
not allowed to store the identified information there. They have to have that in a separate place where if they need to, move back and forth between identifiable and de-identified,
So what do
that
they
all has to be
consider
controlled.
identifying information? What's the minimum you can strip out to meet that requirement of de-identified?
Yeah, so I'm not actually sure that is
It's
a
not well
hard
defined,
a
right?
hard requirement. Like I said, the HIPAA aspect is not my strong suit. I just had a kind of standard anonymization script that we used on all the images. But there's other things to think about too, as far as what actually constitutes identifying information. Because if you look at an MRI, you look at it slice by slice, you have no idea who it belongs to, but you can
Yeah.
actually reconstruct a 3D model of this person's
There's
face
their face. Yeah. Yeah.
and see the face, right? So they've even developed methods now that will,
Soften
process
it.
the MRI and destroy the face and keep the brain intact. So you
Yeah.
lose the face, but you keep, the brain data.
Are there
Uh,
tools out there that do that today?
yeah, there's some command line tools. I think if you look at FreeSurfer or FSL, they'll have something like that. And I think that's one of the things that they may even consider putting into an automatic pipeline. For something like Xnap, which is just a program that researchers use to archive all their data and all the different projects that they use. They can run processing pipelines on those images as they come in and
Yeah.
automatically deface the MRI.
Yeah. Yeah. Just and de-identify in other ways with the
But as
Dicom.
far as is that necessary for what, being HIPAA compliant? I don't know the answer to that, right?
Now let's go back to Xnap. We've talked about Xnap before,
hmm
and we've looked at it at GE. We've looked at that tool and how we could support it from our packs and our VNA products. Can you describe? Because I think a lot of folks in the enterprise imaging space never heard of Xnap. They don't know that something like that exists, right, to help support researchers. And maybe that's a good tool that could be used in sort of a hybrid model where you have tools the researchers are using that are interfacing with the clinical side of the house. So maybe just describe for us what Xnap does and how it might be
Yeah,
used.
yeah. So I'll go ahead and start with kind of returning to the first point I made about how the money from research comes from the ground up.
Mm-hmm.
And so what you end up with is people that are acquiring these images, and they have a hard drive, and the images just go onto a hard drive, and that's it. And then, maybe they'll make copies of the images and put them somewhere else on the hard drive so they can do some processing and stuff like that.
Yeah.
And if you get people who are really sophisticated, or they're processing tons of images, I have one group that's creating their own SQL database and kind of organizing the images that way. So
Like a
so
PACS.
everything is a lot. Yeah, they're basically making their own research version of PACS on a server machine that they have somewhere.
Okay.
And so there's a lot of effort going on within the small groups and stuff like that. And the neuroimaging community, which is a huge user of just research imaging in general, has been really driving a lot of what's going on with research imaging. They've noticed the need for this program, and there's kind of an open source initiative going on right now from University of Washington, I believe, that is building kind of what researchers need to be able to archive their data safely backed up and very flexibly, and it can be extended to deal with many different types of data. So the main thing that we use it for now at Methodist, it really did start in our neurology department. And once we saw how useful it was, the whole research institute as a whole wanted to kind of, let's start maybe trying to expand this to different research departments that use imaging. Cardiology is a big one. And then there's a lot of imaging that goes on even just with animals in our research institute and stuff like that. So Xnap can be used for that kind of image storage. And the way it works is it's essentially a web app that has, a SQL database behind it. And so a researcher doesn't have to worry about, if my machine crashes, am I going to lose all my data? No, they just go to a website, they can log in. It has all their projects there. It has all the imaging data organized. And it also has the ability to have processing pipelines as part of the installation. So anybody can design their own pipeline using a Docker container, for instance, and run that on the images that are on the SQL database. So they don't even have to download the images onto their computer necessarily. They can do the processing right there, and that works really good for lots of different types of standard pre-processing.
And I just want to make clear for the audience that when you say a web page, it's a this is not hosted at University of Washington or Washington University or whatever it is. This is, you take ownership, you take this software, you install it, and build out your own infrastructure. So it's stored in that infrastructure that's on-prem.
Yeah, exactly. And that's another thing I wanted to mention is that there are kind of proprietary solutions for this kind of problem, right? But researchers are not able to spend that kind of money on a proprietary enterprise level kind of research thing, and there's so many different ones, and they don't always necessarily do what you need. I think the main benefit of Xnap over those kind of solutions is that it's open source and it's extensible. And if you have a research lab, you hopefully also have an engineer who's able to work with this and kind of mold it how it needs to be molded.
Able to stand it up, configure it, and interface it to downstream systems.
And make sure it's backed up.
And that's really, I think, where the the connection to enterprise imaging and PACS and VNA really comes in is if you have something like Xnap, the hope is that could be interfaced to the clinical systems, right? And that could be the conduit through which the researchers are accessing that data, if that makes sense.
Yeah, and so we've actually just started kind of poking at that a bit with the newest version of Xnap, actually. I mean, we're kind of just right on the bleeding edge of what they've been able to do. So this is a new feature, but they have the Dicom query retrieve plugin for Xnap. So you can install this plugin, and it gives you the option to, in your project, if you have the IRB approval and if you have the correct access, you can connect it to the PACS system at the hospital. And if you have the MRN and the modality and the study date, you can upload that CSV and do a query on the PACS, see all the images, and then select which ones you actually need to import into your project. And Xnap will automatically de-identify those images as they come in.
And that's part of the pipeline that you would configure, right, for that data flow, I guess.
Right.
And you brought up an interesting point there, which is access controls and permissions. Enterprise imaging people are always worried about who can access the data. Are we auditing access to the data? And when the topic of research comes up, it starts to become a concern, because we say, well, how do we know who can access what data that for researchers, and how do we audit that? If that's all getting funneled through something like Xnap, then the onus of that security could fall to Xnap instead of falling on the enterprise imaging systems, right?
Yeah, so I think the way that we try to deal with that is when a project gets created on Xnap, they apply to our department. Okay, we would like to create a project. And we confer with the IRB committee. We say, okay, they want a project. Here's the details. Here's what they need. And they'll send us back an authorization saying, yeah, that's okay. And then we go ahead and give them the access.
So I think we're running close on time here. I appreciate the time and talking about research today.
Yeah, Brian, thank you very much for having me.
All right.